Database query methods. So we've got our database built, and now it's time to work with the data stored inside of our tables. And in this nugget, we're going to look at how we can query the tables using just plain old SQL, structured query language statements. And we'll look at stored procedures and how we can build these compiled queries that sit on the server and are executed on the server and are great for performance purposes, as well as security. There's some other reasons you would want to use stored procedures, which I'll talk about when we get there. So let's jump into the outline for this nugget. We're going to start with just working with SQL queries. Here we're going to take a look at the four major statements that everyone needs to be familiar with if you're going to work in a database engine. The select statement for pulling data, reading data, the insert statement for putting data into tables, the update statement for modifying data that's already in tables, and the delete statement for removing data. So we'll look at all of those and how to work with them from Visual Studio 2010 Express. I'll show you how we can create some queries there, and we'll do it both by hand and work with the Visual Designer, because there's query builders that are built into a lot of these database software products these days that make it really easy to build your queries through a GUI. Once we're comfortable with writing our own SQL statements, we'll jump into stored procedures. I'll show you how to create stored procedures, the simple kind and the kind that takes parameters. Because a lot of the times when you call stored procedures, you need to pass data into them so the stored procedures can do something with the data, like put it in a table or update a table or data inside of a table, or maybe even perform some processing, some logic on the data. So I'll show you how to create a simple and a complex stored procedure, and then in the last area here we'll get a demo going on how to work with these objects, both queries and stored procedures, from inside of an application. We're going to take the WinForm application that we built in a previous nugget that was basically our reminder user interface, where we could modify, create reminders, and rather than that application work with the data, on the fly. We just created a reminder and that was it. As soon as we closed out of the application, the data disappeared. We're going to turn that into a full-blown database application so we can persist our reminder data into the database. So on subsequent launches of the application, it'll look like we never left it. All of our reminders will still be inside of our tree. All right, so let's get to it and talk about how we can work with queries. We're going to get familiar here with the structured query language. So let's head over to Nugget Lab. And once we're in here, I'm just going to head down to the Start button, fire up Visual C# 2010 Express. And once we're in here, I actually created a project called 21-rdbms_queries. And this is what we're going to use in the last part to take our reminder form here, just to kind of refresh memory. And we're going to turn this into a full-blown database application that uses the tables we built in our database design nugget to work with the reminder data and persist that information permanently. All right, so we'll come over to this. I just wanted to get that project open. In fact, we'll just push this over to the side there and head over to our Database Explorer. And here is our reminders database. If I expand it here, we'll get a connection going to it. And here are the tables that we were working with. And just to remind you a little bit on the data that we're going to be working with to write queries against, I'm just going to right-click on these and show the table data, each one of them. Right-click, show table data. Right-click, show table data. So we've got these three tables out here, and one cool thing you can do here if you want to work with this, you can kind of drag them off and get them all on top of each other. Look at that. There we go. So now we've got three tables. These are our three tables. Here in the middle is our reminder table. And this is what we did in a previous nugget where we built our table. We put some data into it. I added another record into here called Take Out the Garbage, and just with the alert time, a date, all that good stuff. And I actually had another record in here that I deleted because I messed it up. So that's why the auto numbers messed up, and we have a 1 and a 3 for our reminder ID. And if you remember, this is our intermediate table here that ties our users to our reminders. And we have two records in here, one for each reminder, and they're both tied to my user record here. So let's say we wanted to write some queries to pull the data out, because we're going to use this query and pass this data back into our application to use. So we're going to need to write a select statement to pull the data out of it. And there's a couple of ways you can do this. The first way I'm going to show you is just writing queries. If we right-click on a table and choose New Query, it's going to bring up a little designer here. What tables do you want to include in this query? And we're going to include all of them. So I'm going to click on all of them, choose Add, and hit Close, and see that's going to give me another window here. And let me just close out of these tables that I had open. There we go. And so this is called the Query Builder. And you can use this in big database platforms. This is why what really made Access popular is you don't really need to know the language in order to write queries. You can use the query designer here to say, okay, well, what columns do I want to return here? Well, I can get name, due date. Actually, in the reminder table, I probably want them all. So we can click on star. And that'll give us, down here, it'll start writing our statement for us. Select star from reminders. And because we have other tables that we added in, it automatically joined them based on the ID because we named them the same and they had the same data type. So they're already joined together. And you can see that's what, after the from statement, we have these inner joins down here that join the tables together. So now, up here in our select area is where we're going to pull the columns we want to use. And in fact, we wouldn't need anything out of our intermediate table. That's why it's an intermediate table. It sits in the background and just links our two tables together. So really all we would need for a reminder is the email address. So up here after select and before from is going to be your what they call the select list. And this is where we just list out the columns that we want to return. Now if we left it like this and hit execute, here's the execute button. Here is the data that shows up right down here. Let me just hide our Database Explorer here. And so here's the data. That we just executed that query, and here's the data to come back. All of our reminder data plus the email added onto the end of it. Now we could get fancy here. In fact, let me just hide the designer and hide our grid there and just work with SQL so we can get familiar with writing code. Because in order to write stored procedures, we're not going to have a fancy designer. Although you could, theoretically, use a designer and just copy some code into a stored procedure. But it's always good to know how this stuff works because I guarantee you'll be troubleshooting SQL code in the future. So it's good to get this stuff down, just kind of get familiar with the syntax and all the keywords and the language in general. So if we only wanted specific reminder data, we could do reminders.reminderID, reminders.name, and then email address. If we execute this, see, we'll only get those 3 columns back. So that's what the splat is. Reminders.splat, otherwise other people call it star, select star. That returns all columns in that table. So if we do it this way, we're saying give us everything out of the reminders table, but only the email address out of the users table. And there we go. So the from then just tells us what table we're pulling it out of. And in a very simple select statement, let me just copy this. And then in a very simple select statement, we could do something like this. Select star from reminders. That's as easy as it gets, right? That's just going to pull everything out of the reminders table. There it is. And you can see the designers like to do this, like to actually replace your star with everything when it's like that, when you only have one table involved. Now let me paste our other one back in here. Joins are where things get a little tricky, but really tricky for us anyway because we have multiple tables involved. But it's really just a matter of linking these tables together based on their common ID. So here we're joining reminders to users, our intermediate table, on the reminders.reminderID equals the reminders to users.remindersID. So we're joining our reminders table to our reminders to users table by linking the reminder ID in both tables. And then we're doing the same thing with our users table. We're joining that onto our intermediate table as well, based on the user ID. So doing this join just gives us the ability to link these tables together. So in our select list, we can pull back whatever columns we want out of these tables. And you can see that, again, here by looking. And you can see the designer didn't update. You have to actually click on the area here, and then it updates based on your SQL statement. There we go. So now we can pull and work with any columns out of any of these tables. They're all joined together. Now we can also add filters onto our statements, so we can hunt for specific data within our queries. So we could do where, and that's the name of the statement here, where, in our case here, let's do a simple one, reminders.reminderID equals 1. So if we wanted to hunt for a specific reminder here based on the ID, we could do this. And in fact, when we get into update statements and our application, when a user is inside of our application, they're always working with one reminder at a time. So we're going to have to have a way to update a specific reminder, and we're going to do that by the ID. So we're going to be passing in an ID to our stored procedure, so we'll only apply an update to a specific record. So that's where the where clause is really going to become important in update statements. But select statements is too. This is how people build search engines. They pass all this data into a stored procedure. A lot of it is just one big where clause on top of these, with lots of logic inside of the where clause. That has ands and ors if you want to filter by multiple columns and such. And you can do lots of things inside here. Dates, you can say if this date is between a beginning date and an ending date. We can do it based on alert time. You can do text searches and full text searches inside of here. So there's a lot of things you can do inside of a where clause when it comes to finding the data you want to find. So that's all accomplished through the where clause. Now let's take a look at an update statement. If we wanted to update specific data inside of a table, say for instance we wanted to update the email address, my email address inside of my user record, we could say update followed by the name of the table, users, and now we have a set statement. What columns do we want to update? Well, we want to update email address equals me at cbtnuggets.com. And this is where you'll definitely want to put a where clause in an update statement, because if we just ran this and there were 1,000 user records in this table, every one of their emails would get updated to my email. So that's why where clauses are always important inside of update statements. So here we could say where user ID equals 1. And if we were to run this, it'll tell us one row is affected by the last query. And then it'll obviously turn our designer here into an update query designer, and you can see that's the field that we're updating. So now if we, let me just copy this code here. We'll just do a select star from users. There we go. My email address was changed to garth@cbtnuggets.com. And let me just turn that back here by putting it back to nuggetlab.com. And if we hit execute, it's going to let us know again, one row is affected. And now if we just do a select star from users, it should be back to normal here. And there it is. We also have insert statements. And by the way, you can change these rather than me just typing these in here. If you want to change the query type here to an update, you can right click and choose change type. See, we're at a select right now. We can change it to an update, and there you go. It'll kind of write the code out for you here, so you don't have to write it all out. And let's change this type here to an insert statement. So here's what an insert statement looks like. It's insert into followed by the name of the table that you're inserting, and then a column list, followed by the actual values here. So if we wanted to insert a new user here, how about John? And we can give John the password here of 1234556. Oh, that's a nice secure password, huh? And then how about john@nuggetlab.com? And you can see when working with strings in SQL, it's a single quote rather than the double quote we're used to in our programming world. So there we go. If we were to execute this, and you can see we don't have the auto number in here with user ID because it's an auto number. It'll take care of itself. So you can kind of ignore auto numbers inside of your insert statements. And also, if you have columns that have defaults, you can optionally add them too if you want to override the default. Otherwise, you can leave them there and the default will get filled in. So if we were to execute this code, it'll tell us one row is affected. And now if we change this to a select, give us all of them. Hit enter. Oh, here we go. Execute. There we go. There's John. He got a user ID of 2, and now he's inside of the users table. Now the last major SQL statement we're going to look at here is the delete statement. And if we just want to delete John's record out of here, let's change the type here to a delete statement. It'll write that for us. Delete from users. And again, we want to add a where clause in here so we don't accidentally delete my record as well. We're going to say where user ID equals 2. And if we execute this, it'll tell us one row is affected. If we turn this back to a select statement, giving us all the columns, executing it, and now it deleted me as well. It shouldn't have, oh, you know why? It kept our where clause in there. That's why it did not delete us. There was a filter on it. So there we go. There's my record back in there. John's gone. And that's the basics there of select, insert, update, and delete. Just all ways that we can work with data, whether we're reading it, adding new, modifying existing, or removing it. Now let's take this to the next level and see how we can work with stored procedures. So we want to come down to our stored procedures folder, and underneath our database, right click, choose add new stored procedure, and that'll give us a template here for creating a brand new stored procedure. And this is the SQL code here, just create procedure followed by the name of the procedure. So I'm just going to double click on change this to get reminders. And now this is parameter based here, this stuff. So I'm going to get this out of here. Let's just create a very simple stored procedure here. And this one's just going to say select star from reminders. That's it. Grab everything from the reminders table. Very simple stored procedure. And all we need to do is hit save here, and that will save the stored procedure into the database. And now you can execute it just by right-clicking and choosing execute. That's going to execute the stored procedure, which is going to execute our SQL statement. And here's the output. Here is our table. All the columns, all the data within the columns. And that's really it as far as creating a basic stored procedure goes. And you can see now this create turns into an alter, and that's how what we call DDL statements in SQL work. Is when you create it for the first time, it has to have a create. When you want to modify it, it'll be an alter. DDL stands for data definition language, and that's what these SQL keywords are. Where this is the select, insert, update, deletes are called DML, the data manipulation statements. Now let's create two more stored procedures, one with an insert statement so we can add new reminders from our application, and one with an update in it so we can update existing reminders that already exist in the data. So I'm going to right click on stored procedures and choose add new stored procedure again. This one, let's call this update reminder. And now we need to use these parameters because with an update we need to pass in all kinds of data, basically all this data here, including the reminder ID, because remember we need that where clause so we make sure that we update the record that we intend to update. So what we can do is uncomment this code just to help get a structure going here, the structure of parameters. And parameter list has to be enclosed inside of parentheses. All right. And let me just get rid of all this stuff down here. We don't need it. Also, we don't need output because we're not going to return any data through an output. You can fill up this parameter and then catch it from another application or even SQL if you're writing this code yourself. So if you need to output just a single value, it's a good idea to do that. And a lot of times, some people like to get an ID back. If you're inserting data and you want to send them back the actual ID that got inserted, which we may want to do in our case, then you can certainly use an output parameters. But let's just keep this simple here and create some parameters. Our first parameter for an update statement is going to be a reminder ID. Just so, again, we can apply this to our filter. So let's do reminder ID. This is an integer, and we're not going to have a default on it because we want to make sure it gets passed in. So by not putting a default on it and not doing this, we're saying it's a required parameter. So if they don't pass anything into reminder ID and update in our update reminder store procedure, the store procedure is going to throw an error, and the user then in the application will receive that error. Now the next parameter we're going to work with here is going to be name. So we do an @ sign here followed by the name of the parameter. Again, all your parameters have to be preceded with this @ sign, followed by the data type. This is going to be an nvarchar 255 is the name of the length of the name column. And by the way, if you're not sure, in Visual Studio you can actually just click on this, and I'm going to hit F4 to bring up the properties even though it's right over here. You can also hit F4 to bring them up. But once you click on it, this will give us all the information about that column. So we can see its data type up here, we can see its length here, and if it's nullable or not here. So that's handy to know there. So let's just put that back over there and then put a comma for our next one. Next one's going to be due date, so let's put a due date in here. This is actually a date time. Looks good. Alert time is going to be a small int, and then notes is actually going to be also an nvarchar. I believe we made this one the max. Let's find out here. Yep, length -1. Anytime you see -1, that usually means unlimited. All right, and because this is an optional field, we can do an equals null on the end of it. And that means they do not need to pass this in. It'll default to null if they don't pass this parameter in. Then we can do an is complete. This is a bit. We can say =1 on there, or actually =0 as our default. And then an as at is enabled is a bit =1. So that's it. We got our parameters set up for our update reminder store procedure. Now it's just a matter of, after the add statement, writing the actual update statement and passing these values into the update statement. So let's do that. Update reminders, and now we're going to have a bunch of set statements in here. Set, we want to set the name of the column inside of this table equal to the name parameter. And now sometimes you're going to see this, because name is an actual keyword inside of SQL. You can do this. You can surround it here with brackets, and now it won't treat it as a keyword. So it's good to do that here if you're using, column names that are keywords inside of the SQL language. So after we've got our name set, we can use a comma for multiple ones here. The next one's going to be due date. So due date equals and due date. And then alert time equals and alert time. We have notes here. Notes equal at notes. And then we've got is complete equals and is complete. So you see we're just matching here columns to parameters. And finally, is enabled equals is enabled. And now here's the important part, where reminder ID equals and reminder ID. So this update statement is going to apply all these values to the respective columns in the reminders table where the reminder ID equals the reminder ID getting passed in. So let's save this stored procedure, and there it is now underneath our stored procedures. And let's create one more. Let's get our update stored procedure going. So I'll just click add new, and I'm actually just going to paste in, wrong one, paste in our update stored procedure here, and turn this into a create, turn this into insert reminder. And now the reason I do that is because a lot of these parameters are the same except reminder ID. Because this is a new reminder, we will not have a reminder ID. The system needs to generate that. And now we just need to turn our statement into an insert statement. So let's say insert reminders. And we can follow this with our column list here. So we can say reminder, or actually we can completely ignore reminder ID because that'll get created for us. Name, due date, alert time, notes is complete, and is enabled. And then again, we do a values followed by the actual values that get passed in. And again, we should also put our brackets around our name since it's a keyword. And in our values clause then, we can just start typing in or copy and pasting all of our parameters in here. So name, due date, actually I'm probably faster typing than copy paste. Due date, alert time, notes is complete, and is enabled, just like so. Alright, that should be it for our stored procedures. So we've got an insert reminder here, and if you save this, if this was invalid SQL in any way, it would actually yell at us and tell us that. So we know we're good. We've got 3 stored procedures. Now we can execute them. You can also test them from here as well with your parameters. In fact, if we wanted to insert a new reminder, we just right click, choose execute, and see this little dialog box that pops up here that says, hey, you want to fill in some values? So we can say test, date time here. How about we just do 1/1/2012, alert time 5, notes here none. We'll leave that as the default. We'll leave these all at the default. We hit OK, and it's good. If we get this here, one row effective, we know that it worked. And now we can just right click on our table, show table data, and there's our test. Reminder ID of 4. All the defaults went into place that we didn't supply anything. And there it is. And by the way, it also shows you the actual statement that was run here. So this is the actual statement. It just did a dbo.insert reminder and then filled out parameter name equals value, parameter name equals value all the way through, and that's what got executed to through the SQL Express engine, and the data went in. Now let's take a look at how we can utilize these stored procedures and work with our data inside of a .NET application. So we can use this data and really make a true live database-enabled application. So let's just minimize this stuff, push it over there, and get our Solution Explorer back out here with our properties. And we're going to work inside of our reminder form here, and specifically, I added a new class called DB Engine that's going to take care of all the working with our stored procedures and basically all the database code that we need stored inside of this class. And the really neat thing about this is we don't have to do a lot of work inside of our application because all that code is already there. Really, the only thing we need to do is take the part that we use to create our reminders manually and just turn that to hit this class, which will go to the database and get the reminders. So all of the code is going to be contained inside of this DB Engine class that I put together. And if you're going to work with databases, then you're going to need to bring in the system.data namespace and all the classes in there. If you're going to be working with SQL Server specifically, you also need to bring in the system.data.SQL client namespace, because this will give us access to all the classes that allow us to create connections to a SQL Server database and then throw queries against them and get data back from them as well. And it's a very small class, but this contains everything we need to connect to a database, pull the data back, and then push data back into it as well. So what I did here is I created in our constructor, so anytime somebody creates this class, they need to pass in a connection string. And the connection string just tells our application where to go find the data, what server to find the data, what database the data exists in, and then any security credentials. So I'll show you how we pass this in when we get into the application. But really all this is going to do then is instantiate a new SQL connection object, passing in that connection string, And now we have a live connection to the database that we can use other objects to throw commands to and to pull data back, put data into, and that kind of stuff. So I made two routines in here. We have a get reminders routine, which I'm going to show you how we can just take a simple query and pass it to SQL Server and get some data back. And then I have a save reminder routine, which we're going to use both of our stored procedures in to put data into our database and to pull to update data that's already in the database. So first, let's talk about get reminders. So what this does is this just returns a list of reminders. And if you remember back in our form, I'm just going to go into the code window here for the form. At the very top of it, oop, that's not our form. This is our form. At the very top of it here, we've got a module level variable called underscore reminders, and this is what we looped through to add the reminders to the tree view here inside of our form. So that's why inside of our database engine class here, we just return a list of reminders. So we're basically just going to replace that list in our form with the list that gets returned from the database. So what I do first here is just create a string variable called query, and this is going to be our query. Select star for reminders. Give us everything out of the reminders table. And then we need to create a SQL data adapter. This is what allows us to pass in a query and a connection. So this is going to do all the work, the SQL data adapter. And then I also create a data table object. And this data table, think of it as just a virtual table. It's a table that's in memory for our application to use, just like the table stored on the database side. And all we need to do to execute this query against our database using our connection is call a SQL DA, the name of our data adapter here, .fill, and pass in the data table. So that's going to take the query, execute it through the connection, fill up this data table, and now all we need to do is, first of all, create a list of reminders. So there's an empty list of reminders here, and we're just going to loop through the data table using the data row object. So for each data row inside of the data table.rows collection, we're just going to fill up a reminder class. So we create a new reminder class. We set the reminder ID equals to the reminder ID column inside of the data row, then the name, the due date, alert time. So every column we're just filling up, and then we're adding this reminder to our list. So once this loop's done, this list will be filled up with all the reminders from the database, only as classes that we can work with here in the programming world. And then we just return that reminders. So whenever someone calls this, it's going to fill up in our reminder form this reminders list with data from the database. Pretty cool. And like I said, we don't really need a lot of code to make this happen. So if I scroll down here into our load reminders tree, I added 2 lines of code. That's it. This is all the code I added to the interface so far. Is classes.dbEngine. So we instantiate a new DB engine, and we need to pass the connection string. And what I did here is I just stored the connection string. If we go into the properties of the project here, into settings, I made a setting called connection string and just pasted the value of the connection string. And where did I get this connection string from? Well, what I did is I went to View, Other Windows, Database Explorer, which we have right here. If you click on the MDF here, since we're already connected to it, see this connection string right here? This is it. This just tells us the data source is our local SQL Express. That's what it is. And then since we're working with a file here, you just do an attach DB file name, which browses right to that reminders.mdf file. That's it. Integrated security, and then some other things on there. But all I did was this. I right-clicked on this, copied the string, and then just pasted it into here as a string. So now we've got the connection string, which just tells our SQL connection object where our database is and how to connect to it. So that's it. I just passed in doing a properties.settings.default.connection string, that's the name of the setting, to our engine class. And now our database engine is aware, it's connected to the database, and now we just set that reminders variable at the top of this form equal to our database engine.getReminders. And that'll connect to the database, execute the query, make our class list of reminders, and then pull it in here. And then all this code we already built in a previous nugget that just loops through all the reminders and adds it into the tree. So if we hit execute, we should, check it out, we get all of our reminders loaded into even the test one we just added. And now again, I didn't have to make any changes to the code itself because this just enumerates the classes, just goes through the properties in the classes and ties them into the interface. So that's all taken care of just by us filling the classes and returning it back into our reminders list. Pretty cool, right? We didn't have to do anything extra there, but just fill up this list with the reminders that are from the database rather than from us statically creating them. So the only other thing we have to do here is work with our stored procedures inside of our engine and then turn our save button on our form into something that calls our save reminder and passes the current reminder in, so it kind of does the opposite of what we did up here. We're going to take all the data out of the reminder and put it back into the database. So that's why we have a save reminder routine where whoever calls this will pass in the reminder that the user is currently on in the interface. And now we need to do one little piece of logic here. We need to figure out if this is a brand new reminder or if it's an existing reminder. And that's where the reminder ID is also helpful. Because if the reminder ID equals 0, guess what? This reminder didn't come from the database. If the reminder ID has a value that isn't 0, then it obviously did come from the database, so we can run the update. So that's why we have just a little logic split in here with an if statement that allows us to determine which stored procedure to run. So if it's 0, we're going to run the insert reminder stored procedure. If it isn't, we're going to run the update reminder stored procedure. And I actually didn't name these with an SP in front of them, so we got to change that here. And it's very simple to do this. We're going to use SQL commands this time. The SQL command class allows us to create commands, hook up stored procedures, attach them to a connection, fill out the parameters with the values from the reminders, and then execute them. Very simple. So we create a SQL command. We set the command type equal to stored procedure. You could also do .text, in which case then this command text, instead of being the name of the stored procedure, you could type in your SQL statement. Right? Pretty cool. So that's that. Get it back to our stored procedure here. And again, we have to tie the connection property of our SQL command equal to our connection that is at the top of this class that we create again when the class is instantiated here. And then we just add parameters. So parameters.add with value, name of the parameter, parameter value. So you just got to make sure your names match up or you'll get errors here. So we have a name, we extract the name out of the reminder class that gets passed into here. Same with due date, alert time, notes, and we're not even, we could also, actually we do need to, sorry, with the insert we do not need to worry about our defaults because those will get taken care of for us. With our update though, we do, because remember we did add those, so we're going to have to add that into here. But the big thing with the update is making sure we also pass in the reminder ID. And now I do remember we did put defaults inside of our update stored procedure, so we shouldn't have to add these in here, but I'm going to do it anyway because we would want to give the user control to be able to enable and disable and mark it as complete as well here, the reminder itself. So let's just do an is complete on this one. And this is going to be an is enabled, passing in the is enabled property of the reminder. Alright, there we go. So again, the execute non-queries would actually execute this. This just basically means we're not expecting any return results back, so we don't have to worry about catching any data coming back from the stored procedure. Alright, let's head over into our interface and make the change so we can save reminders from the interface. So I'm going to scroll up until we find our save reminders button. Here it is, right here. So here's the save, the click event on the save button. And now we don't need these two lines of code anymore because this is really because we were creating these reminders in memory. We had to do a check. Well, that's all controlled at the database level through the reminder ID now, so we do not have to do that anymore. And I'm just going to paste in our instantiation code for our DB engine, and then we just need to do a dbe.saveReminder and pass in the current reminder. And that's it. Pretty handy, right? So the real nice thing about a design like this where we're using object-oriented programming in classes is we have this loose coupling between our interface and our database code. And that's what's nice too here is we can contain all this database code inside of one class in here that's just really going to return reminder objects and accept reminder objects. And then we don't have to change a lot of code here in the interface, really just to call the class to get the reminders. So that's it. 4 lines of code to turn our entire interface into a fully database functioning application. Pretty cool, right? And then the rest of the code is all contained for database access inside of there. Now let's run this and see if it works. And it's not going to work initially because there's one thing I wanted to show you here. So just to show you why it's not going to work, let's hit run and let's modify, say, our test reminder here, and let's change this to, how about, watch more nuggets. Alright, nothing wrong with watching more nuggets. So we'll do this at 5 p.m. right when we get out of work, right? Get out of work and go right back to work watching nuggets and learning something. And remind us 10 minutes before then. Let's hit save. And what's going to happen is it's going to bomb out on us. It's going to say execute non-query requires an open and available connection. The connection's current state is closed. So why did that happen? Well, the reason it happened down here and not up here is because the data adapter automatically opens the connection for you. So you kind of get that luxury with the data adapter. Commands, well, not really. So we need to do that ourselves here. And in fact, if we just do a SQLcon dot open, that's it. That'll open the connection before it executes the query. And we need to do the same thing down here. So underscore SQLcon dot open. And that's that. And then the connection will get automatically closed when this class gets deinstantiated or destroyed, which it'll do when it goes out of scope inside of our interface. Now let's try and run this. Let's click on our test reminder. Let's say, how about watch more nuggets one more time. Make this 5 p.m. Set it to 10 minutes. And how about bring lots of popcorn? And we'll save this and see that it worked that time, because inside of the save button, the very last thing we do is call load reminders tree again. So after we saved it to the database, it went back to the database, grabbed all of them and brought it back in and reloaded the tree. So that's why it works. And now we can click around, click back on it, and it saved our changes. And we can verify that. Let's just close out of the application here, go into our Database Explorer, go into our tables, right click on our reminders, show the table data, and check it out. Our test record now turned into watch more nuggets with all the data that we supplied to it. That all went through the stored procedure and got updated appropriately. So it's really fun when you start getting into building applications, especially working with databases, to see things come full circle. When you start pulling data out and putting data in and seeing it in action, it's a good feeling and it's really fun. So one thing I'm going to challenge you to do, and you know, I always had this problem when I was learning programming. I'll never forget it. Is once you kind of have some skills to do some of this stuff, you're like, all right, well, now what do I build? And you're always trying to think of things to build, and it just feels like a mental block. I know I had it. I know I've talked to many developers who have had it, because you've got the skills. So what do you do with them? What kind of application do you build? So what I'm going to challenge you to do here is add an email address to this, and expand this application so the interface supports multiple email addresses. And just to kind of give you an idea of what you could do here is you could have maybe a user ID area where you'd choose the user, and then when you chose your user, it would go to the database, find all that user's email addresses, and then you could pick all the email addresses that could be attached to this reminder. And not only that, but you could also go into the service nugget where we built a Windows service and expand that so it could then send emails to multiple users. And also it could be using the database. You could attach that service to this database so it could be pulling the reminders out of the database rather than what we did over there as well, create them statically inside a code. And then you'll just have to remember when you send the email to also send an update to the database to set the isComplete flag to true so you don't send emails over and over again. Alright, so there's some good challenges for you. Just giving you ideas here how you could expand this application to work with the database and how you could expand the Windows service to work with the database, because then you truly would be going full circle, making the service hit the database and making this application utilize the email addresses that we already have stored inside of the database. Alright, so in the CBT Nugget we took a look at database query methods. I started you off here with just some basics on what the structured query language is all about. We took a look at the select, insert, update, and delete statements, the 4 big data manipulation statements that you'll be using to work with data stored inside of a database. So we used Visual Studio Express to kind of create these queries, and we did kind of both a mishmash of working with the designer and also just writing some code and getting familiar with what it looks like. And then we jumped into stored procedures and saw how we could create a simple stored procedure and also a couple of stored procedures that take parameters. One was an insert, one was an update, so we could do some data modifications and data additions into our tables. And at the end here I took you through a demo on how we can hook up our front ends and the applications we build in Visual Studio.net to the back-end databases so we can work with the data stored in them. I hope this has been informative for you, and I thank you for viewing.